So, Mr. Hardy, what's osmosis?
Movement of, think of what water molecule to a membrane, something like that.
Movement of water molecules from a region through what? A different
Differential
permeable membrane.
Semi-permeable membrane.
Same thing. The same thing. But they have to learn different terms that they might use in the exam. Alright, because sometimes it's MCQ, so you have to be familiar. So you have semi-permeable membrane or a differential permeable membrane. So now in terms of concentration of water molecules, do you agree that dilute solution would have the highest concentration? Pure water would have the highest concentration of water, eh? Of the highest right? Dilute with aqueous solution, right? Than concentrated aqueous solution, right? You following this statement?
Dilute occludes.
So we are compatible with solid, liquid, and gas, right? In terms of appreciating them in real life. Right, so we have to know when we're moving from one. Right, but some substance can move directly from solid to gas. Some substance you can move directly from gas back to the solid. Alright? From solid to liquid, this is melting. From liquid to gas, boiling, or if you leave it like at room temperature, it can evaporate. Right, what's the difference between evaporation and boiling?
Evaporation can take place at any temperature. That is, it doesn't need to be boiling. It doesn't need to be above 100 degrees Celsius for evaporation.
No, you see, in chemistry, we don't specifically say 100 degrees Celsius. 100 degrees Celsius is the boiling point of water, but different compound will boil at different temperatures. For example, ethanol will boil at 78 degrees Celsius, right? So if you're making a general statement about boiling, you can't say 100 degrees Celsius because that's specifically the boiling point of pure water.
Yes.
Go again.
So,
Between boiling and evaporation.
I was saying that evaporation can basically occur. So I don't even want to say it.
Try Mr. Harding. The difference between boiling and evaporation.
Boiling is evaporation is the release of gas in the air. While boiling is, I don't know.
They both of them release gas in the air. Alright? So two things to differentiate between them. So boiling normally takes place at the boiling point of a given compound, while evaporation will just take place at any given temperature. Right? In terms of the particles moving from liquid to gas, for evaporation, it's only the surface molecules will move. So if I have this water here, if you leave it here for like, say, a year, the bottle will go empty. But the water particles, they are just basically moving from the surface. Right? It's whenever you are boiling it, the liquid water molecule will move even from the bottom and go up. That is why if you are boiling something, you will see gas bubbles. That should indicate to you that it's not just the surface molecules that are going in the air, even the molecules at the bottom of the liquid. Next is condensation, moving from gas to liquid. And this is basically you have to cool the gas to bring it down to liquid. So in this direction you are cooling, in that direction you are heating. Right? And from liquid to solid is freezing. Some substance, they move from solid to gas. For example, like you've seen like camphor ball, or you might have dry ice, I think it's carbon dioxide. It will move from the solid straight to the vapor. Alright? So we don't have a liquid phase state. And if you're moving from the gas to the solid, term is called deposition. Right? So in this direction, you basically heat. In this direction, you are cooling, right? Let me see its temperature here. No. Let's use. Alright. So let's see. So this here. Alright, so this curve, heating slash cooling curve. Now, let's use water as the example. We know that if we have the water in the freezer, it will form ice, which is solid, right? If we put it at room temperature, it will melt to form a liquid. And if we put it on the stove, then it will convert to gas. So you get the picture. So we look at, say, for example, water, in which we can appreciate all three states with water clearly. Now, if you take the ice from the freezer and say, for example, you put it on the table in a beaker, right? It will, as time progresses, temperature, say for example, below here would be below 0 degrees Celsius. So if we have it in the freezer, it's normally below 0 degrees Celsius. I'm using water as a specific example, right? Below 0 degrees Celsius, you'll have ice only, water in the solid state. Whenever you reach 0 degrees Celsius, the solid will start to convert to liquid. However, the temperature will not change from 0 degrees Celsius until all the solid ice convert to liquid. That's a very key thing to know. So that is why melting freezing point, if you notice the temperature, even though time and we are supplying heat, it's one straight line. This would be like 0 degrees Celsius if we are using water. The temperature will not increase from here to here. So all the solid, if we're supplying heat, all the solid would have to be converted to liquid before the temperature starts to increase. Likewise, if we have water at 0 degrees Celsius and we put a thermometer in it and put it in the fridge, the temperature of that water will not start to drop below 0 degrees Celsius until all the liquid is converted to solid. The same process. So when we are melting our freezing point, so melting is from solid to liquid and freezing is going from liquid to solid. So melting our freezing point, the temperature remains fixed throughout that time period. While from liquid to gas is the boiling point, right? So if you have pure water on the stove and you put the thermometer in it, you'll realize that the temperature of the water will not go above 100 degrees Celsius. Alright, it will stay 100 until it's actually finished. So that's the boiling point. And between the phases, it will not go higher, the liquid itself.
But you have to convert the gases.
Yes, if you have like water vapor, so for example, you have the oven and you have water vapor in it. The temperature can be higher than 100 and you still have water vapor there. But all of it would be in the gaseous form. Any questions, any comments? Alright, so that's it for states of matter.